What? What is a kilogram meter per second squared? A unit of. What is a kilogram meter per second squared? A unit of. Per second squared. What's the symbol, or what's the abbreviation for kilogram? AG. Okay, there's a hyphen that just means multiplication. What's the symbol for meter? What's the symbol, abbreviation for second? And when you square it, you put a little 2 by it. Kilogram meter per second squared. What is that a unit of? What is mass? What's the variable we use to represent mass? M for mass. What is a meter per second squared? No, because one's a variable and one's a unit. You usually don't mix your variables and units. So meters per second squared is acceleration. So it's mass times acceleration. What is mass times acceleration equal to? Force. So I ask again, what is a kilogram meter per second squared a unit of? Unit of force. This is the definition of a Newton. 1 Newton is equal to 1 kilogram meter per second squared. What is a kilowatt minute a unit of? Keep your mask on, Michael. What? What is, so watts or kilowatts is a measure of power. Minute is a measure of time. And power times time, unit of energy. Another thing you could have done is remember that kilowatt hours is a unit of energy. If we change the time unit, it does not affect what it's a unit of. If we change hours into years, if we change kilowatts into watts, or megawatts, or anything like that, it's still a unit of energy. What is an inch? An inch is a unit of what? Distance. Alright. Um, a foot per second per year is a unit of what? What is the equation for velocity? Velocity is what? What is speed equal to? Speed is what? Speed or velocity is distance over time. Do we have a distance unit? A foot is a measure of distance. Do we have a time unit? Year. So that's a time unit. However, we have another time unit. So we have a distance over time and time. This is not velocity, because velocity only has one time in this equation. What is the units for acceleration? Acceleration is usually measured in meters per second squared. There are two time units on the bottom and one distance unit on bottom, or on the numerator. So one distance over two time units, this is acceleration. Let's do another one. What is a joule a unit of? Yes, joule is the de facto unit of energy. Alright, let's see. What does MHZ stand for? Megahertz. And what is megahertz a unit of? Wavelength is a length. Frequency. So hertz is the de facto unit for frequency. Yeah, it's just gonna be the units though. So this quiz only deals with units, and most of them will be the base unit. What is month a unit of? A month is a unit of time. So let's go over quickly what all of our equations were. Speed is equal to a distance over time. Acceleration is equal to change in speed over time. Equivalently, you could just say it's speed over time. And speed, we just solved the equation, just recall the equation for speed. That means it's distance over time over time. We had force. Force is equal to ma, mass times acceleration. We have power. What is power equal to? I times Z, or power is equal to energy over time. What is milliamps a unit of? Alright. And what is megavolts? A voltage? So what would milliamps, megavolts be a unit of? Power. Because power is current times voltage. Alright. What is a kilogram? Alright, let's test this out. What is a kilogram times meter squared over second squared? When given this, it's best to write it in the abbreviated version. So kilograms times meter squared per second squared. Keep a mask on. What's the equation for kinetic energy? Equal to 1/2 times mass times velocity squared. So mass, kilograms. Huh? This is just a quiz, it's not a daily rate. I'm probably going to put all the equations on there. It's only dealing with units. So plugging in the units into the equation, we get kilogram meters per second squared. We distribute the square out, that's meters squared over second squared. So this whole thing is energy. Yes. What about a Newton meter? Well, we know force is equal to mass times acceleration. Force is equal to Newton, or is a Newton, and we get kilogram meters per second squared. Let's plug this in for Newton. We have a kilogram times a meters per second squared, and this whole thing is being multiplied with another meter. Meter times meter is meter squared over second squared. Same thing we had right here, it's still energy. If you can get everything down to meters per second and kilograms, you can use the base formulas to derive the equation. Potential energy for gravity is mgh. Mass is kilograms. Meters per second squared, and height is in meters. We can see right here, saying this, Newton. So we have a mass, and so we have a mass times acceleration due to gravity. So this has to be a Newton. Height is in distance, so it's Newton times a meter. Let's see, what other equations have we have? What's a mega ohm? A unit of. So I've been mostly avoiding the prefixes, but you can just ignore prefixes. All this mega means is a million ohms. We have mega, which is 10 to the 6th or a million. We have kilo, which is 10 to the 3rd or 1,000. And we have the base unit, and then we have centi, which is 10 to the negative 2 or 0.01. And we have milli, which is 10 to the negative 3, which is 0.001. Deci is 10 to the negative 1. Deca is 10 to the 1. But deca and deci are very hard to spell. We also have hecta. Hecta would squeeze in right here at 10 to the 2nd. The opposite of the time. But all these can be ignored. The base unit is just ohms, and ohms is the measure of resistance. Let's see. Can I cover all the units? Milligrams. What's that a unit of? Nope. Ah. Weight. Of course. We have different weights on different planets. You weigh 1/8 as much on the moon as on Earth because gravity is 1/8 as strong. Oh, yeah. So what are all the units of temperature? What are all the units of temperature? So we have Fahrenheit, Celsius, Kelvin, Celsius, and Fahrenheit. These are just things. These are three. No, homework grade. All right, so we have meter is a measurement of length or distance, right? We have a meter per second is a measure of speed or velocity. We have a meter per second squared is a measure of acceleration. What is a meter per second cubed? That would be a jerk. Meter per second to the fourth. That's a snap. A meter to the second to the fifth. Meter per second to the fifth. That's a crackle. And meter to the second sixth is indeed a pop. Curious. The derivative is a position calculus. You have normal position x. You have the first derivative of x is velocity. Second derivative of x is acceleration. And then we go into jerk, snap, crackle, and pop. Jerk is the only useful one. After that, there's really no reason to get down this point. This is basic. So a jerk is how much your acceleration is changing. Acceleration is how much your velocity is changing. Velocity is how much your position is changing per time. So a snap is how much jerk is changing, which really very few systems actually need that. And so someone made a joke. Let's just call them snap, crackle, and pop. And no one could think of a better name for them, so it kind of stuck. One thing is snap. We call it how do I change it? Jump. But unless you're trying to land something on the moon and make it hit like land on unless you're trying to aim a rocket and hit like a little tiny 1 meter square thing on the moon, this changes in that level of detail. Probably not needed. I think that's going to be all the units on the test. However, I want to go over a few extra ones for you guys because this week is going to be the. And Michael, put your mask on and lift your head up. So next semester we begin chemistry. So this is going to be the end of. It's going to be the end of physics. So let's go over a few variables and things we haven't covered. What's a meter squared a unit of? Meter squared. What's that a unit of? So it's distance squared. What's that a unit of? Let's think about square feet. What's square feet? Area. The unit of area. Meters cubed. Feet. Volume. Coulomb. Coulomb. It's electric charge. Actually, what current is equal to coulombs per second. The amount of charges that pass by per second. Henry. What do you think Henry would be? Inductance. So if you were to take some wire and put it in this shape, it's known as a solenoid. And what that's going to do is the magnet. So when electrons move, they create magnetic fields, and the magnetic fields will then resist the flow of electric movement and it'll slow it down. Basically, it kind of keeps it kind of smooths out current. If you were to have a very large inductor, and you were to try to break that circuit, what an inductor does is smooth out current so that it can't change as easily. It's not like a resistor; it doesn't slow down electricity. It slows down the change in electricity, changing current. So this is a very big. So a transformer acts as a very big inductor, and whenever they need to kill the power, it's a very big inductor, and an inductor basically says current is going to resist change. So when they throw this breaker, the current wants to continue going, and it will increase the voltage to any amount of voltage necessary to continue the flow of current. So anytime they trip the breaker, current is going to resist changing until over time. That right there is so much current that you could kill anyone remotely close to it. We also have farads. They are a unit of capacitance. You might have heard of capacitors. Do it this way. So some very common derived units. Radian is a measurement of angle. It's a meter divided by meter, so it's technically a fictitious unit. A meter divided by meter cancels each other out to one. This is another fictitious unit. I've never even heard of it. We have Hertz, we have Newton. Pascal is the unit of pressure, which is equal to a Newton divided by meter squared. That's a column. Or column. Yeah, I've got that stuff. Too long. Magnetic flux, the Weber. So we usually talk about flux density in Tesla. Um, a lumen. However, these are the only major units in all physics. Mass, kilogram, second, amps, Kelvin, volt, and cadella. Everything else is derived from these units. So, for example, you deal with flashlights. You might have heard of a lumen. It's a cadella times the fictitious unit of stirred radion. Might have heard of the gray. Never done implementation. There is two spellings of Ray, the American version and the British version. And I want to say with the A is American. The one with an E, Gray. The Gray is the American version of spelling, and with an E is the British version. So with an E is British English, and with an A is American English. Only exception is Greyhound. We still use it for that. Yeah, that's it. Oh, I will say this. I forgot this one. Hertz. So hertz is equal to 1/2. So it's, and this is frequency. No, or parallel is 1/1/1. Frequency is equal to 1/period. Period is measured in time, and time is 1/frequency. Or period is.